All right, let's look at phylogenies. So a phylogeny is an evolutionary history of an organism and its relationship to other organisms. And why we look at a tree is because a tree is kind of looking at a representation of that phylogeny. So this is showing a phylogeny of organisms of life. So we have bacteria, archaea, eukarya, and then you see various things off of there. So what we do is scientists are going to look at differences and similarities in organisms, and then they're going to reconstruct a tree of life or a phylogenetic tree. So the phylogenetic tree is going to show which organisms evolved from other organisms, in which order, and when. All right, so if we go, here, this is showing what I want to get to. So it shows the relationships among organisms and is a hypothesis about the evolutionary history of those species. All right, and so we're going to construct a tree based upon comparative anatomy or genetics. So we look at this here, and looking at how we look at phylogenies, is wherever we have a speciation event, and that's what that is trying to show, or speciation events, that is where also we have this common ancestor. So back here we had a common ancestor to fish and birds and humans and rats and mice. Here's where we had a common ancestor to birds, humans, rats, and mice. Here, common ancestor to humans, rats, and mice. Here, common ancestor to rats and mice. Okay? So, what this is also showing is that all of these organisms here are more closely related to each other than they are to that organism. And all these organisms are more closely related to each other than they are to that organism. And these are more closely related to each other than they are to that one. All right? And that's how we read a phylogenetic tree. Now, as I said, this is showing just another phylogeny with birds and crocodiles are more closely related to each other than these are to lizards. And all these are more closely related to each other than they are to mammals. Okay? This is looking at tree based upon comparative anatomy, right? Lions and hyenas are more closely related to each other because they both possess retractable claws, all right? And they also have two ear bones, where wolves and bears only have one, okay? So, all right, and this is looking at it on genetics there. So we're just gonna move on here. So some things that can trip us up is that, like this trait here, wings, evolved twice, right? We know it evolved more than twice, but bats have it, birds have it, insects have it. But we have to look at other characteristics, not just wings, to see if things are related, okay? Bats produce milk just like us. They have hair just like us. They're warm-blooded just like us, all right? So in some cases, you can't just go by resemblance here. You need to look at the DNA. So the African golden mole and the elephant are more closely related to each other, even though the mole looks a lot more like the shrew. All right? So let's move on to cladistics. And cladistics is where you construct a phylogeny based upon clades. And a clade is a group of organisms related by descent. And they have key common characteristics. And so you're going to build a phylogeny based upon what are known as derived characteristics. Okay? And so you make a cladogram, which is a branching diagram that represents a phylogeny, and that's what we're trying to show here. Now, this is what you guys are going to be doing for exercise 11 in the lab. All right? So I'm going to give you this, and then you're going to construct this on the right side. So what we have in here is what is known as an in-group. And these are the organisms being evaluated. And then we also have an out-group, and that is a different organism from the group. And the out-group serves as a baseline for comparison. So when we look at these, we're going to look at ancestral characteristics and what we call derived characteristics. All right? So organisms on the cladogram share a more recent common ancestor. All right? And it also portrays the order in which evolutionary events occurred. All right? So let's look at how we do this. So here is a lancelet. So we can see the lancelet there. That is our outgroup. And so when we make this chart here, we're going to look at if that characteristic is ancestral or derived. So if it's ancestral, we give it a 0. If it is derived, we give it a 1. All right, so derived, it's evolved. All right. So with the lancelet, lancelets don't have a vertebral column, they don't have hinged jaws, they don't have legs, they don't produce an amnion, which is a membrane that surrounds the developing embryo and fetus, and they don't have hair. All right. So they get 0s on all that, and that's what we have with the outgroup. The outgroup has no derived characteristics, so all ancestral. All right. Next is the lamprey, which is a jawless fish, but it does have a vertebral column. So it doesn't have a jaw, it doesn't have anything else. Next is the bass, we see there. Bass does have a vertebral column, it does have hinged jaws, but it doesn't have legs or an amnion or hair. All right. Next is the frog. Frog has all 3 of these, right? So it has a vertebral column, has a hinged jaw, has 4 walking legs. Does not have an amnion, so they don't have this protective membrane around their eggs. All right, it does not have hair either. Now the turtle has a vertebral column, has hinged jaws, has 4 walking legs, has an amnion. Okay, now outside of that amnion is kind of a leathery shell. All right, they do not produce hair, and a leopard has all of these. So an amnion with us placental mammals. That's a membrane that breaks when, quote unquote, the water breaks, right? So what mammals did is instead of laying an egg, we keep the egg inside of us, okay? So, has all these characteristics, the leopard. So when you make your phylogeny over here, what you're also going to put on here is you're going to put these lines indicating the traits that everything this way has, right? So the lancelet has nothing. Right? Nothing there, right? But then the lamprey has a vertebral column. So you can see everybody else after here has a vertebral column. So you make a little dash there and you put vertebral column there. So we're saying all these animals have a vertebral column. All right? Next is hinged jaw. So you make a little line there with hinged jaw. So everything this way has a hinged jaw. All right? Next is 4 walking legs. Everything here has 4 walking legs, so we make a little dash and put that in there. Here, amnion, both of these have the amnion. And here, hair, only the leopard has hair. And so we make these little marks there to show who has that trait and who doesn't. Now, we used to use traditional taxonomy, and these are phylogenies based upon information about the structures of the organism, which is known as morphology, and the biology. So we typically, though, do cladistics these days.